Hey guys, so in today's lecture, we are going to discuss site selection considerations. So, in last lecture, we have discussed design considerations. So, what things we need to consider before selecting any site that where we are going to install a wind turbine. So, and we can harness the wind energy. So this is an important topic which is asked in GTU many times. So it is very much important to consider all the aspects like technical, environmental, social, economical, and every other aspects before considering any site or before erecting the wind energy conversion system, it is WECS. So the main criteria in selecting the site for wind energy, we will divide in this many factors. So first factor is average annual wind speed. So how much wind is available on that site. So uh, and what is the speed of that wind. So the power available in wind increases rapidly with wind speed. So therefore the main consideration for locating wind power generation plant is availability of adequate and uniform average wind velocity throughout the year. That is how much velocity of wind is that throughout the year, not on a particular days or months. So the wind velocity is very critical parameter. So the power in the wind through a given cross sectional area for uniform wind velocity can be given as that power pt is equal to, sorry, power pt is equal to kv so where k is constant, so where k is constant, from this equation the total wind power from free wind stream increases as the cube of the wind speed. Therefore the wind velocities available should be in the range of, so we should be at least in the range of 5 to 25 meter per second throughout the year. So this is because this is a cube of the wind speed, so wind speed is very much important. Then as the building forests offer the resistance to the air movement, the wind farms are located away from the cities and forests, so flat open area should be selected. So generally open area means banks of rivers or oceans, banks of oceans where no resistance to the air is there. So in such area should be selected. So flat open area where wind velocities are very high. So that is the second point. Then third point is altitude, sorry, second point is altitude of the site. So altitude of the proposed site means what, at what height the wind turbine should be installed. So higher the altitude, ground experience strong winds than lower altitude ground. So the much higher you go, the more wind speed you will get from the ground. Thus, altitude affects the electric power output of the wind WECS system. So, wind velocities must be measured by anemometer. So, we should measure the wind velocities at different heights before installing, that at each height what is the wind velocity. So the velocity of wind increases with height given by the relation V is proportional to h raised to 1 by 7. So which means that V raised to 7 is proportional to h. So which means that seventh power, uh, so wind is increased. So the relation is applicable for heights between 50 to 250 meter. So altitude also affects the air density and thus power in the wind, and hence WECS electrical power output. So velocity depends on height raised to 1 by 7. This is also an important point. So after that, wind structure. So that is third, wind structure. So at proposed site, wind should blow smooth and steady all the time. That is, wind velocity curve should be very flat. So wind, especially near the ground, is turbulent. Means at the ground it is very turbulent. It is not in uniform. What we can call uh, laminar flow is not achieved. So it is very turbulent and gusty and changes rapidly in direction and velocity. So it should be very smooth and the flow should be laminar. So that is required. So in such a way, wind structure should be proposed. Then fourth point is ecology. So if small trees, grass or vegetations are present, all of which destructure the wind, then the height of the tower will increase. So if some crops or some small plants are present, so that can uh, destructure the wind, then the height would then if you are installing, then the height should be increased a little bit, which can cost to the system, so which can increase the cost of the system. So that is the ecology, if you want to save the ecology also. Then next point is nature of the land and its cost. So the site selected should have high load bearing capacity, so it would reduce the cost of foundation. So the cost of the land where we are going to install the wind turbine should be low, so that it can reduce the initial cost of the system. So that is cost and nature of the land. Then next point is transport facilities. So there should be transport facilities for transportation of heavy machinery, structures, materials, blades, etc. to chosen site for installation, which means that the road should be there so that we can transfer all the heavy machinery. So it should not be that the road must be pakka, not kacha roads, where there may be problem in rainy season or something. So transport facilities should be available. Then nearness of site to load structure. So nearness of site to load structure. So the site should be located near to the load to which power is supplied. Means the demand of the power requirement should be nearer. So the location of the site near load center reduces the cost of transmission lines and the losses occurring it. So the losses, the transmission loss can be reduced. Then away from location localities. So the selected site should be away from localities so that sound pollution caused by the wind turbine does not affect the habitants in near areas. So four types of sites are considered as suitable. It is plain land sites, hilltop sites, seashore sites, offshore shallow water sites. So that are main four sites which are uh, suitable for the wind energy system. Then next is advantages and disadvantages of wind turbine. So I have divided advantages and disadvantages in tables. So first we will see advantages. What are the advantages of the wind energy? So first is it is renewable type of source, so it will not be depleted with over time like fossil fuels. So there is coal, petroleum, it is not getting depleted. So it is a renewable which will which is and which will come in future. So that is a renewable advantage, that is an advantage. Then second is eco-friendly. So wind energy generation is eco-friendly and does not pollute the atmosphere. So unlike in the case of coal and oil, which may generate pollution to the environment and greenhouse gases, so that is not the case here. Then next is cost effective. So the installation cost of the wind power plant is competitive compared to the conventional, that is coal power plant. So since there is no fuel cost and low maintenance cost, so the cost of energy produced in the long run is almost free. So that is the case. Then next is fuel less. So wind energy system does not require fuel and its transportation. So it is generally fuel less. So fuel is not required. Then fifth is wind energy. That is in the large portion of the world. Wind blows for 320 days out of 365 days in a year, and thus this gives them an advantage over sunlight in direct conversion program. It is so if in sunlight uh, you get around 300 sunny days in India and in other world different days, and even you get only sunshine hours are very less compared to wind energy. So these are the advantages of wind energy. Now we will see disadvantages. So first disadvantages, it's very much fluctuating. So the wind energy speed is very much fluctuating, so it's not constant. So it is a disadvantage over sunlight, that in sunlight you know that how much intensity of sunlight you will get. The sunlight is a constant but wind energy is very fluctuating. Then storage, that is if suppose very high wind speeds are flowing, then it is necessary to store wind energy in some other forms, because there is a limit how much wind energy can be converted, so it need to be stored. If higher than the threshold is the if higher than the threshold wind energy is obtained, and then it should be used later during the calm when the wind energy is very low. So that is a disadvantage. Then third, favorable winds are available only very few geographical location. So the location where the wind energy is available are very few. There is also a disadvantage, whereas in sunlight the sunlight is available each and every most of the uh, parts of the world. Then high capital cost. So at present it is about 3.5 crores per megawatt. So 1 megawatt to install, it is 3.5 crores. So it is very much high than in the sun, harness in the sunlight. So it is 3.5 crores. So then it, next point is it causes noise. Bird hits, that bird may hit to the wind turbine, wind. Then uh, land erosion, then impact on the wildlife. So these are the main disadvantages. So these are the advantages and disadvantages of the wind energy conversion system or wind turbine. So now next we will see application of wind energy. So the energy extracted from the wind is initially energy in form of rotary, translational, or oscillatory mechanical motion. This mechanical motion can be used to pump fluids or can be converted to electricity or heat. So major applications we have grouped into three categories. So first is mechanical power. So applications that require mechanical power. So first is wind pump. So in remote areas, low power turbines are used for producing mechanical power for pumping water, and these are known as wind pumps. So low power turbines can is used. Then next is heating. So a paddle wheel and other turbulent fluid systems are used for direct conversion of mechanical power into heat, and the available hot water is used as much employed for space heating. This paddle wheel experiment, which is very much famous, of Joule Thomson's, so it can be used for heating. Then next is sea transport. So wind turbines are installed on board to power propellers in ferries operating on short routes. So that is a application. So where short route uh, ferries are used, so there you can use wind turbine to power the propellers. So that is also an application. Then next is electric applications. So one is off grid, another is on grid. So what is off grid? So machines of low to medium power range up to 250 kilowatt can be used to supply power to isolated populations, farms, cooperatives, space heating and cooling, commercial refrigeration, desalination to small industries. So these are the main applications where electricity can be used. So the generator may operate in standalone mode or may be connected to a mini grid system. So you can use a standalone also connected to the grid. So that is off grid electrical power source. Then grid connected. So large wind turbine where 250, more than 250 kilowatt to a few megawatt capacity are used for supplying power to the grid, directly to the utility grid. Wind farms consisting of large arrays of wind turbine generators are used for this purpose. So that is grid connected, where high power is generated, and off grid you can use where low power is generated. So these are the applications of wind energy. So these are the main applications of wind energy conversion system or wind turbine. So we'll see in next lecture various energy development in India where the wind energy plants are installed and where in future potentials are there. in different states of India. So that is the last topic of this chapter, and then we will see new chapter. So thank you very much.